Hi guys, I hope you had a really good spring break and we'll start back with some more area formulas. I know some of you had asked me about taking a retake. I'll be posting some things later on this week that you can do so you can do a retake on Friday if you like. This will be notes number 4. And I hope you guys are taking your notes or at least watching the videos. If we get to come back to school, we'll have a notebook test where you can use your notes if you've been taking them. Okay, one thing I want to say and to remember is these are not drawn to scale. Okay, I'm basically freehanding them, and we're going to use 3.14 for our calculations for pi. Okay, so our first example. Now, normally you have to divide these shapes into more than one, but since I'm drawing them, you'll have an idea of what the two shapes are. Okay, the first one has a square bottom, and then on top it has a triangle. It kind of looks like a house. Okay, and what they give me as measurements is 5 meters on the side of the square. As you notice, the tick marks mean all 4 sides are the same. Okay, we're also given the height here of the triangle to be 6 meters. So we want to know the area of this whole irregular shape. So we have to do 2 shapes at a time. We want to do a square first. Area can be base times height, or for squares, they usually say side squared. As you're doing these, I would expect that I see some work. I'm sure that a math app probably doesn't do all the work. Okay, this triangle is 1/2 base height. So your base of your triangle is down here, which sits on this square, which would be 5. And the height is the altitude of the triangle, which is 6. So 30, take half of that, would be 15. Okay, once you find both areas, on this notes 4, we're going to be combining. So you're going to add those together. Okay, and this is what I would expect that I see on your assignment today. That I can see you've done 2 areas and that you have added them together. So you're going to need to show some work to get your full credit today. Okay, the next example looks like this. And what I'm given on it is 3 centimeters for the width. The length here is 11 centimeters. And then from the end all the way up to the tip of this thing is given to me as 20 centimeters. Now remember, these are not drawn to scale. Okay, so what I want to do on this one is to divide it so I can do a rectangle and a triangle on the end. Okay, and know that I am freehanding this, so it's a little sketchy, but hopefully you can tell I'm going for a rectangle and a triangle. Okay, so for rectangle, we're going to do area equals length times width or base times height. Since I presented this as a length and width, we'll just use that formula. Okay, and then on the top here, I've got this triangle. Sits out to the front. So area is 1/2 base height for any triangles. So the base would be this length, which is the same as the width on the rectangle. Okay, and the height, I'm going to have to deduct the height. Okay, the entire length is 20. Up to the edge of the rectangle is 11. So if I do 20 minus 11, that'll give me this distance on out to the triangle. Okay, and remember, this is not drawn to scale. 20 minus 11 is 9, and that definitely doesn't represent 9. But oftentimes the figures are not represented and drawn to scale. So 3 times 9 is 27. Half of that is 13 and a half. If I add those together, and get a total. Okay, so as you're doing these, I would want to see that you did give me a total and you found it by adding. Okay, and once again, if you have your own calculator you want to use, you can. You can also keep using Desmos, but know that we don't have an end of the year assessment for sophomores this year. Okay, so here's another shape. It looks kind of the same, but on the end of this one, I'm going to do a semicircle. So something like a circle on the end. So I'm going to be dividing it into a rectangle and a semicircle, half a circle. Okay, and what I'm given on this rectangle is 15 centimeters. That represents out to here. Okay, and that would only be from point to point on the rectangular side. Okay, then I've got this little circular side, which is a half of a circle, semicircle. And what they're going to tell me on it is right here, the radius is 5 centimeters. Okay, so we're going to divide this into a rectangle. And we're going to do a circle, but of course we're just going to do half a circle. So area is going to be pi squared, but we're going to do half. So I'm going to say that's a semicircle. Okay, so for the rectangle, I was given 15 this way, but I wasn't told the width. Okay, so I'm going to have to base that off this radius. A radius is halfway, so if halfway is 5, if I double that, 5 and 5 makes 10. So this side has to also be 10. So length, width, 15 times 10. Okay, and once again, that's base and height if it was standing up. Length and width, base and height are used interchangeably. Okay, we're going to use 3.14 for pi in our calculation. Our radius was given to us as 5, so we'll do 5 squared. So we have 1/2 times 3.14 times 5 squared. I'll just double check my calculation. 39.25. And then I'm going to give a total area by adding these together. $189.25. Okay, our next example is going to be a rectangle on the bottom. And then it's going to have like a trapezoid shape on top. It kind of looks like the Pizza Hut building. So on our rectangle bottom, we're going to be given 20 centimeters for those two sides. And then these are 10 centimeter sides. The top up here is 15 centimeters, not drawn to scale. And this part of that trapezoid is 3 centimeters. Okay, so we got trapezoid and we've got rectangle. Okay, by now we should be pretty good at rectangle, the length and the width in any order. Okay, trapezoid's one we've not talked about today. Base 1 plus base 2 times height, then you got to take half of that. Okay, the two bases are the bottom and the top here. Okay, and the way we know their bases is they're connected perpendicular to the height. So this height is a right angle perpendicular to the bases. So 20, 35, 35 times 3, and half of that. 52 and a half. Okay, and then we get our total. Add those together. Okay, and then the last shape I have for you guys is this parallelogram shape. Top and bottom's the same. The two sides are the same. We don't have any right angles. So it's a parallelogram. And then I'm going to stick a scaling kind of triangle on the end. Okay, so it'll be this odd shape together is what we want the area of. We're given 10 centimeters here. We're given a height, 6 centimeters. Okay, and that 10 centimeters is just the bottom of that parallelogram, and then the triangle bottom we're given as 12 centimeters. Okay, so we got a parallelogram, which is base times height, and then we've got a triangle, 1/2 base height. So for the base, we got 10. We need to know how tall it is, what the perpendicular distance is between the two bases. Because this triangle point lies along the side of this top of this base, from the point of that vertex down to the side containing this line, that's also going to be the height of this parallelogram. So he's 10 this way. If you go straight up, it's going to match here. It's going to be 6. So 10 times 6, 60 centimeters squared. And we'll be adding that to this one. Triangle is 1/2, base 12, height 6. So 12 times 6, divided by 2, 36. And then our total, 60 plus the 36, gives us 96 centimeters squared. Okay, that wraps up our notes today, guys. Notes number 4. I've given you several different shapes. A lot of times if they're presented to you in the book, you might have to draw these little lines that separate it into two shapes. Figure out what your two shapes are. Because I presented them to you in notes, we kind of knew as I was drawing what the two shapes were. So this concludes notes 4. I hope this helps you guys. I'll also include a video that you can watch on YouTube that might help you some more. Have a good day and good luck with your assignment. Bye.